Hello guys, you welcome to my channel. Today we want to talk about logarithm. Logarithm. Logarithm of a number, say n, to base b is the power to which b must be raised to produce n. Now by definition, when you talk about a logarithm of a number, let's take for instance that the number is n and the base is b. So the log of n in base b is going to be the power to which b must be raised to produce what? N. That is, if I have log of n in base b like this, so let's say the value is x, hence n is equals to b to the power of x. So this is the value of x is going to be the value for log n in base b. Do you understand this? For instance, let's take I have the log of 8 in base 2. So for me to know the value for log of 8 in base 2, let's say it's equal to what? X. So if this should be the case, 8 equal to the power of x. So I can write 8 in base 2, and that's going to be 2 to the power of 3 equal to the power of x. So this and this can cancel, x equal 3. Hence, log of 8 in base 2 equal 3. Okay, let's see another example. If I have the log of 100 in base 10, let's say this equal what? Y. So, you know, the value of y is going to be what? It's going to be the value for log 100 in base 10. So, 100 equal 10 to the power of y. So, this can be written as 10 to the power of 2, and this is 10 to the power of y. This and this can cancel, y equal 2. Hence, the log of 100 in base 10 equal what? 2. Do we get this now? Okay, if this should be the case, you can try this now. Try the value for the log of square root of 2 in base 2. So, what will be the value for this? Pause the video and give it a try. Okay, let's say this equal what? X. So this is going to be the square root of 2 equal 2 to the power of x. Hence, this is same thing as saying 2 to the power of 1 over 2 equal 2 to the power of that. This and this cancel. X equal 1 over 2. Hence, log of square root of 2 in base 2 equal what? 1 over 2. I believe we understand the definition of logarithm. Now, there are two types of logarithm. We have a logarithm in this form, the common log that we have to be in base 10. So when I have log in base 10, this is called common log. All together. So this is called what? Common log. I can write it as log in base 10, or I just write it as what? Log without what? Indicating the base. So when you see a log that the base is not being indicated, it shows that that log is a common log and it is going to be in base 10. Then I have the natural log, which is also written as log in base e. So if I have ln, is the same thing as log in base e. They all obey the same rules of logarithm, of which that is what we are going to discuss now. So let's quickly look at the laws of logarithm. So the scope of this class is not to prove the law. Subsequent video you can watch for the proof of each law. So the first law is the addition law. If I have log of x in base b plus log of y in base b, my result is going to be log of xy in base b. Likewise, if I have log of xy in base b, my result is going to be log of x in base b plus log of y in base b. For example, if I have log of 8 in base 2 plus log of 2, okay, let's say log of 3 in base 2. This is going to be the log of 3 times, sorry, the log of 8 times 3 in base 2, and this will end up giving us the log of 24 in base 2. So that's for the first one. The second one now is the difference log. So if I have log of x in base b minus log of y in base b, my result is going to be log of x over y in base b. For example, if I have log of 10 in base 2 minus log of 5 in base 2, my result is going to be log of 10 divided by 5 in base 2. So my result is going to be log of 2 in base 2. There is a law that binds this, but don't let us talk about the law yet. So let's go for the third one. So the third law states that if I have the log of x to power of m in base b, my result is going to be m log x in base b. So for example, if I have log of 8 to power of 3 in base 2, my result is 3 log 8 in base 2. Do you understand this now? So the fourth one now, if I have the log of x in base b to power of n, my result is going to be 1 over n log x in base b. Are we together? Okay. This can also, for example, if I have the log of 5 in base 4 to power of 2, my result will be 1 over 2 log of 5 in base 4. Do you understand this now? So by the time, whenever the base is taking what power, so if the power is going to get to this place, it will be the reciprocal of the base. Do we get that now? So the fifth law now, if I have the log of a in base a, or let me say, okay, I've been using b, let me say log of b in base b, my result is going to be 1. So log to its own base, log of a number to its own base is going to be 1. So if I have log of 2 in base 2, my result is going to be 1. Okay, the sixth law, and if you look at this here, you can see this is going to be what? 1. Do you understand that? Okay, the sixth law, if I have the log of 1 in any base, my result is going to be what? 0. Log of 1 in any base will give us what? 0. So I can prove that by saying, if I take this one to this side, I will have 1 equal b to power of what? 0. Hence, I can write 1 as b to power of 0, or, okay, 1 is equals to b to power of 0. Hence, log of 1 in base b is going to be what? It's going to be 0 by the definition. Okay? So, if I have, for instance, log of 1 in base 5, my result is going to be what? 0. Do we understand that? Okay? Let's look at the seventh law. So, if I have the seventh law, the log of x in base b is the same thing as saying 1 all over the log of b in base x. It's known as the law of reciprocal. And if I, for example, if I now have the log of 2 in base 3, this same thing as saying 1 over log of 3 in base 2. So the eighth law is known as the change of base law. So if I have log of x in base b, I can change this to base a by saying log of x in base a divided by log of b in base a. So I just successfully changed the base to a. Do we understand? For example, if I have log of 8 in base 2, and I want to convert it to base 10. So this is going to be log of 8 in base 10 divided by log of 2 in base 10. Do you understand this now? Okay, so let's look at the last one. So though you might not be familiar with this, if I have that b is raised to power of, let's say, a log x in base b, my result is just x to power of a. So that's to tell you that this and this would cancel. And this law can also be in this format, b to power of log of x in base b. This is just the same thing as saying the result is x. So this and this would cancel. So you can watch the proof in my next video. So let's take some examples now. But before we take the example, let us summarize the whole of the law on our dashboard here. Okay? So reason why we want to summarize the law is for us to know whichever one we are going to be making use of as regard any question given to us. Okay, so we have the first law to be the log of x in base b plus the log of y in base b. This is log of xy in base b. And we have log of x in base b minus log of y in base b. Our result is log of x over y in base b. And the third one, we have log of x to power of m in base b. Our result is m log x in base b. The fourth one, log of x in base b to power of n. Our result is 1 over n log of x in base b. The fifth law, log of b to base b, is going to give us 1. And the sixth one, log of 1 in base b is 0. The seventh one, log of a in base b is 1 over log of b in base a. The eighth one, log of a in base b is the same thing as, or let me say x in base b. Same thing as saying log of x in base a divided by log of b in base a. So the last but not the least is if b is raised to power of log a in base b, your result is just a. So that's a summary of the law of logarithm. So now let's take some examples and we see how to apply each law to every given question. So our question 1 says evaluate log of 14 in base 4 minus log of 7 in base 4. Okay, if I may ask you now, which of this law are we going to make use of since we have a negative here? Okay, let's check. We are going to make use of the second law. So this will become log of 14 in base 4 minus log of 7 in base 4 will become log of 14 over 7 in base 4. Isn't it? So we just apply this second law. Hence, log of 14 in base 4 minus log of 7 in base 4 is going to be log of 2 in base 4. Okay, I can further simplify this because 4 can be written as 2 to power of 2, right? So this is log of 2, 2 to power of 2. Okay, if I have this, which of the law can I apply again? I think I can then apply the fourth law. So I'll have 1 over 2 log 2 in base 2. When I have log 2 in base 2, the root 5 can be used. That's 1. Hence, my result is going to be 1 over 2. So I can conclude that the log of 14 in base 4 minus log of 7 in base 4 is 1 over 2. Do we understand this? Okay, if you understand this, let's look at another example. Okay, example 2, we are still going to evaluate log of 32 in base 4 plus log of 2 in base 4. Okay, which of the law can we apply to this? We make use of the first law. So if I have the log of 32 in base 4 plus the log of 2 in base 4, my result is going to be log of 32 times 2 divided by, in base 4. Hence, this is going to be log of 64 in base 4. Okay, I can simplify this because 64 can be written as 4 to power of 3, isn't it? So this is log of 4 to power of 3 in base 4. Now, if you ask yourself, which of the law can we make use of? So we check the third law. So you see, m log x in base b. So this will become what? 3 log 4 in base 4. So which of the law can we use for this? We have log b in base b to be 1. Hence, this will become 3 times 1, and that is 3. So we are going to have that the log of 32 in base 4 plus the log of 2 in base 4 is 3. Do you understand this now? Okay, let's move to the next question. That's question 3. Okay, so we have to look at question 3 now. Okay, I think we are also going to evaluate. So the question says evaluate without using tables. So we have to evaluate without using tables. 2 log 5 plus log 36 minus log 9. Okay, if you look at this now, we are asked to evaluate without using tables because this log now is currently in base 10. Like I told you earlier, when the base is not what? Specified, it shows that it is in what? Base 10. Now, you can use your calculator to press for this value, and that's the reason why they asked us not to use what? Tables. So they want us to solve it the way it's supposed to be. Okay, if this should be the case, let's focus on these two first. But before we focus on this, there is no law that relates this and this together. But there is law that relates this and this together because there's nothing here and there's nothing here. But it's possible for us to rewrite what is here in when we apply this third law. If you look at the third law, it's equivalent to this. So we can say this is the same thing as log of 5 to power of 2. Return this one back to this place plus log of 36 minus log of 9. Are we together? Okay, if we are together, these first two, we can apply what? This law to. So we have log of 25 times 36 minus the log of what? The log of 9. So this is going to be log of 25 times 36 divided by 9 by applying the second law to this. Hence, we are going to have that log of 9 here is 1, 9 here is 4. If I'm right, 25 times 4 will give us what? 100 in base 10. And log of 100 in base 10 is going to be what? So we can write 100 as 10 to power of 2. Divided in base 10 rather. So if we apply this third law, we are going to be having what? 2 log 10 in base 10. So 2 log 10 in base 10, log 10 in base 10 is going to be what? 1. So we have 2 times what? 1 to give us what? 2. Hence, 2 log 5 plus log 36 minus log 9 is equal to 2. Do you understand this? Okay, let's look at another question on this. So let's take another example. So that's to tell you that you need to memorize all these laws so that when you see question, you will know what to apply and how to apply them. Okay, the next question here says simplify log the square root of 35 in base 10 minus the log the square root of 7 in base 10 plus log the square root of 2 in base 10. Okay, if this is what they ask us to simplify, let's rearrange so that we can have something reasonable. Log of the square root of 35 in base 10 plus log of the square root of 2 in base 10 minus log of the square root of 7 in base 10. Okay, we have not done anything magical here. If this should be the case, the first two here we can apply the first law. So we then have log of the square root of 35 times the square root of 2 in base 10 minus the log of the square root of 7 in base 10. Isn't it? So I can now apply the second law, and I'm going to have log in base 10 of the square root of 35 times the square root of 2 divided by the square root of 7. Okay, class, this will give me the square root. So I'm going to be having log in base 10. Root 35 times root 2 will give me root 70 divided by root 7, isn't it? Okay, if this should be the case, this is the same thing as saying log in base 10 of the square root of 70 divided by 7. Am I right? Okay, and 7 here 1, 7 here is 10. So I'm going to have that log of the square root of 10 in base 10. Okay, from indices, the square root of 10, I can write it as log in base 10, 10 to power of 1 over 2. And we are going to apply the third law by taking 1 over 2 to the other side. So we have log of 10 in base 10. So log of 10 in base 10 is going to be what? Okay, that's 1 because that's the fifth law, isn't it? So our result is going to be 1 over 2 times 1, and that is what? 1 over 2. Hence, log of root 35 in base 10 minus log of root 7 in base 10 plus log of root 2 in base 10 is 1 over 2. Do we get this now? Okay, let's look at another example. Okay, we have to consider another example here. Okay, we have given that find the value of the product. Find the value of the product. Log 3 in base 2 times log 4 in base 3 times log 5 in base 4 times log 6 in base 5 times log 7 in base 6 times log 8 in base 7. So the question says we should look for the product of this. Now, if you look at this question now, absolutely they are not of the same base, isn't it? So let us convert them to another base of our choice. Okay? How we like to convert them to base 10, you can also like to convert them to another base. But the reason why I don't want to convert them to another base other than base 10 is because I have virtually almost all numbers from 1 to 8. That is, from 2 to 8 I have it here. So I can either convert it to base 9 or base 10 for easy simplification. Hence, if I convert this one to base 10, what does the rule state? The rule states that if I have log of x in base b and I'm converting it to another base, it's going to be what? So this will be log of 3 in base 10 divided by log of 2 in base 10 times log of 4 in base 10 divided by log of 3 in base 10 times log of 5 in base 10 divided by log of 4 in base 10 times log of 6 in base 10 divided by log of 5 in base 10 times log of 7 in base 10 divided by log of 6 in base 10 times log of 8 in base 10 divided by log of 7 in base 10. Okay, if that should be the case, this and this can take care of each other, and I have this, So I'm left with log of 8 in base 10 divided by log of 2 in base 10, isn't it? So we don't have any law that binds this. Hence, I can simplify this as log of 2 to power of 3 in base 10 divided by log of 2 in base 10, right? Hence, I have law that bind this. That's the third law. So I will have 3 log 2 in base 10 divided by log 2 in base 10. Hence, this and this can cancel. So our result is going to be 3. Do you understand this now? Okay, let's take another question aside from this, but I believe you understand what happens here. All we do is to change the base. So, but if you know what you're doing before, you can just say this and this cancelled, and this cancelled, this and this cancelled. Then you just have 8 and 2 left. So you can just do the same thing. So in case you are dealing with a multiple choice question. Hence, we can consider another example under this. So we are asked to evaluate. Okay, I think I need to clean this also. I believe you are getting the class right. Okay, we are asked to evaluate 5 raised to power of negative 3 log 2 in base 5 times 2 to power of 2 log 3 in base 2. Okay, class, which of the law can we make use of? So we can do with the last law by using this to cancel this. But don't let us go by that. Let's assume that you don't know this law before. How can you solve this question? Okay, for us to solve this question, or probably, let me just apply the rule first. This and this would cancel, and this would cancel. So I'll be having negative 3 log 2. Sorry. I can't do that yet. I can't cancel that. So the first thing I need to do is I'm going to take this on to the other side. So I have 5 log 2 to negative 3 in base 5. Then times 2 log 3 square in base 2. So I can apply the law now by taking care of this, and this will cancel. So I have 2 to power of minus 3 times 3 to power of 2. And this is going to be 9 divided by what? 8. So do you get this now? Okay, let's see if you have to solve this question normal, supposing that you don't know this law before. Okay, what are you going to do? Let's say, let 5 to power of negative 3 log 2 in base 5 equal x. Let this one equal x. And 2 to power of 2 log 3 in base 2, let it equal y. Okay, if I have this, take the log of both sides to base 5. If I take the log of this side to base 5, I will have 5 raised to power of negative what? Negative 3, 2 to power of 2 in base 5. Then this is in base 5 equal log x in base 5. And this one, I'm going to take the log of both sides to base 2. So I have log of 2 log 3 in base 2 to equal log of y in base 2. So this one will come down. I have negative 3 log 2 in base 5 times log 5 in base 5 to equal log of x in base 5. Am I right? And this one will become 2 log 3 in base 2 log 2 in base 2 equal log y in base 2. So this is already 1. So I'm having, okay, let me take this one down to that side. So I have 2 raised to power minus 3 in base 5 equal log x in base 5. And this one will also become 1. So I'll be having log of 3 to power of 2 in base 2, then log of y in base 2. Are we together? So this and this can cancel, and this can cancel. So I will have my x to equal what? 2 to negative 3. And I'm going to have my y to equal what? 3 to power of 2. So if I take the product of 2, that is x and y, I will have what? 9 over 8, just like what I have before. Okay, let's look at another question under this. So I believe you are getting this. So now let's look at equations now. Equation that involves logarithm. The first question here says find n if log 4 in base 2 plus log 7 in base 2 minus log n in base 2 equal 1. Okay, how can we find this? When you're given a logarithmic equation like this, all you need to do is to write everything in terms of log. So this is 1, and I can write this as 2 to the power of 1. That is, I have to change this one to log also. So I need to think of a number whose base is going to be 2. Are you getting this now? That the log is going to give us what? 1. Okay? You might not understand what I'm saying like that. Okay? The base is 2, isn't it? So let's just write this one as log 2 to the power of 1 in base 2. So this should be log of 4 in base 2 plus log of 7 in base 2 minus log of n in base 2 equal log of this. The base here is what? 2. So write down 2. What you have here before is what? 1. Just put 1 there in base 2. Are you there now? Okay. Now we can now apply the law. For these two, I will have that log of 4 in base 2 times 7 minus log of n in base 2 equal log of 2 in base 2. Abi? Yes. Okay. I can apply the second law now. I will then have log of 2 into 4 times this, that's 28, all over what? N equal log of 2 in base 2. This and this can cancel. Hence, 28 divided by n equal what? 2. If I cross multiply, I have 28 equal 2n. So, 28 divided by n, this and this cancel, and I have 28 divided by n to equal 2. So, if I cross multiply, I will have 28 divided by 2 equal what? 2n. So, let's divide both sides by 2. So this and this will cancel. This one here 1, this one will give us 14. Hence, the value of n is 14. Do you get that now? Okay, let's look at another question. Should in case you have any question, you can drop it in the comment section below. Okay? So we have to consider another question here. Okay, the question here says write without okay, write the equation. Okay, I think I'm getting the question wrong. Okay, the question says write the equation without, okay, the equation 2 log x in base 2 minus x log 1 plus y in base 2 equal 3 in a form not involving log. So we are asked to write this given equation in a form not involving logarithm. How can we go about that? Very simple. Okay, let's see. They are all in base 2, so we need to change this one also to log. So let's take this one to the other side first. So I have log of x squared in base 2 minus log of 1 plus y to power of x in base 2. So for me to change this one to what? To log. The base is what? 2. I'll write it down. And what I have here is what? 3. I'll put it here in base 2. Do you get this now? Okay, just like what I did earlier. Okay, and I can apply what? The second law to this now. So, log of x squared in base divided by 1 plus y to power of x in base 2 equal log of 2 to power of 3 in base 2. This and this can cancel. So I will have x squared divided by 1 plus y to power of x equal what? Equal 8. So if I cross multiply, I will have x squared to equal 8 into 1 plus y to power of x. Hence, this is going to be the equation without logarithm. Do you understand this now? Okay? So we are not asked to look for value of anything there. This is just what they asked us to do from the question. Okay? So let's consider another example. So I want to believe you are getting this class and you can see the way we are making use of the laws. Okay? The next question here says, if log x in base 2 plus log x in base 4 plus log x in base 16 equal 21 over 4, find x. Okay, what are we going to do? At first, you will see that all these equations, all these logarithm rather, they are not in the same base. So the first thing is to make them to be of the same base. So how can we go about that? Okay, can I write 4 in base 2? Yes. Can I write 16 in base 2? Yes. So we can convert everything to base 2 instead of changing the base. So this will become log x in base 2 plus log x 2 to power of 2 plus log x 2 to power of 4 equal 21 in base 4. Sorry, 21 divided by 4 rather. Do you understand this? Okay, we can apply what? Which of the law in order to take this one to the other side? We apply what? The fourth law. So this will be log of x in base 2 plus, this will be 1 over 2 log of x in base 2 plus 1 over 4 log of x in base 2 equal 21 over 4. Are we together, class? Okay. If we are together, then I can take this one back to this place, because if you look at what I have here, it's similar to what I'm having here. So if I have something like this, I can reframe it back to something like this. Hence, this is log of x in base 2 plus log of x to power of 1 over 2 in base 2 plus log of x to power of 1 over 4 in base 2 equal 21 over 4. Okay, there's need for me to write this 21 over 4 in terms of what? Logarithm. So you know how we usually do it. So I have log of x in base 2 plus log of x raised to power 1 over 2 in base 2 plus log of x raised to power 1 over 4 in base 2 equal log. We write down what? The base, which is what? 2. Then raised to power 21 over 4 in the same base. Okay, so everything here is addition, just like the first law. So we then have this to be x times x to power of 1 over 2 times x to power of 1 over 4 equal log 2 to power of 21 over 4 in base 2. So log and log can cancel. Now this one, now I can apply indices to this one by adding the whole of the power, since the base are all equal. So x to power of 1 plus 1 over 2 plus 1 over 4 equal 2 to power of 21 over 4. Okay, if I add this together, for me to add this together, I need to look for their LCM. So the LCM of 1, 2, and 4 is going to be 4, right? So 1 in 4 times 1, that's going to give us 4. Plus 2 in 4, that's 2. Times 1, that's 2. Plus 4 in 4, that's 1. Times 1, that's 1. So I have 2 to the power of 21 over 4. Okay, if this should be the case, this can be written as x equal 2 plus 4 plus 2, that's 6, plus 1, that's 7. So x equals 7 over 4 equal 2 to the power of 21 over 4. So now, for us to get the value of x, we need to multiply the 2 power by the reciprocal of this available power here. So x raised to power 7 over 4 times 4 over 7 equal 2 to the power of 21 over 4 times 4 over 7. So this and this cancel. So x equal, this will cancel this. 7 here 1, 7 here is 3. So that's 2 to the power of what? 3. hence x equal what? 8. So our value for x is 8, which is the final answer. Do you understand this? Okay, if this should be the case, let's look at the last question here. I think this one is kind of different from what we have been doing since. This is going to be our last question. Okay, I'll advise you to lay your hand on more questions. Okay, I have that if log of 270 in base a minus log of 10 in base a plus log of 1 over 3 in base a equal 2. We are asked to find the value of a. Okay, class, this is also simple. The only difference is that our unknown now is quite at a. Okay, let's write this one in terms of logarithm as well. So this will be log of 270 in base a minus log of 10 in base a plus, okay, or let me rearrange this. So that the plus will come forward. So plus the log of 1 over 3 in base a minus log of 10 in base a equal log of, the base is what? A. So we have a to the power of 2 in base a. Do you get this now? So if this should be the case, I will have log of a times, this is going to be 270 times 1 over 3 minus log of 10 in base a equal log of a square in base a. Is that taken now? So I can apply the second law to this now. So I'll have log of 270 times 1 over 3. Okay, what would that give us? Can 3 go in this? Yes, that's going to be 90. So we have 90 divided by 10 to equal what? Log of a square in base a. So this and this can cancel. So I will have that 9 equal what? A square. Hence, a is going to be the square root of 9. So a is 3. So a is plus or minus 3. So you choose the positive value. Hence, this is where we're going to stop the class for today. Thanks for watching. Kindly like, subscribe, and share this within your friends. Have a nice day.